There's a microphone here, but we can hear pretty well. Can you guys hear okay? Did you turn on the recorder yet? It's on now? You're being recorded, that's okay, because we want to show this to even other classes. I have a device here. It can advance your slides, but I'm not going to do that because it screws things up. But it gives you a laser pointer. It's the top button. I'll leave it here for your use. And when you come up, you can connect the HDMI connectors right here. So, oops, this just messed up, so let's go back. Okay, so this is our logo, as you know. This is actually one of the interesting graduating groups. As you know, I'm the director, and as you know, Bill is the program coordinator. And you've seen this before, but I want to remind you where the funds come from for this event, basically the Internet Research Initiative. It's Venki Haranarayan. He's a mentor, has been a mentor every year. He's the founder, he's the funder, he's a colleague, he's one of my former master's students. He got his PhD at Stanford, and he's a friend. And I just want to have you listen to something you may have heard before, but his message is interesting. So.
Hi, my name is Venki Harinarayan, and I'm one of the mentors and donors to the IRI program. And look forward to working.
Whoops. That's a fault of mine.
Hi, my name is Venki Harinarayan, and I'm one of the mentors and donors to the IRI program. Let me start by saying what excites me the most about this program. Give you a short history of the internet to illustrate how and why this program is so relevant to the world we are entering. The internet started as a way to revolutionize communications. While we used to go to the post office and mail a letter, we started using email to sort of instantly transmit our messages across the receiver. Then the internet revolutionized our access to information. Think about the World Wide Web and Google replacing going to the library, checking out a book, and looking up information. Then it revolutionized how we bought products. Think about Amazon versus going to your neighborhood store. And with mobile, we are able to do this anytime, anywhere. And so the world has changed dramatically over the last 20 years. But I will submit to you that what is coming up right now is bigger and potentially more disruptive than what has happened so far. Because today, I believe that a lot of underpinnings and institutions in our society that we have taken for granted over hundreds of years are in process of being transformed. And the world will look very different 20, 30 years from now than it does today in very, very substantially fundamental ways. So as you have seen in the news of the early signs of that, whether it be what does having a free and fair election mean, what should be our expectations of privacy, what does waging war mean online? There are some really fundamental questions that I think are going to define what the future means for all of us. And the thing I like about the IRI program is the interdisciplinary aspect of it. Even though there are some fascinating technical problems that are still around to be solved, I believe that this interdisciplinary focus of the IRI program is the way we have to think about these fundamental issues of the future. It is going to require folks, not just technical folks, but people from different aspects of humanities, sciences, coming together to try to understand the impact that the internet is going to have on our future. And look forward to working with Professor Kleinrock. That itself is always a delight. And again, welcome.
So I invited the new winners to come, the class to follow you, and you're one of the new winners. Why don't you announce your name? Yes, welcome. I want them to get some sense as to what this was about. Maybe some others will drop in, but we'll welcome you a little more later. Okay, in fact, you're my mentee. Okay, great. So, why IRI? You know the reasons. This is more for the new members than before, but just to remind you, it's to tap the pool of innovation that you undergraduates have. You don't have access to these things, so we give it to you. Your ideas die until the IRI prize comes along. It's interdisciplinary, as Venki said. That's an important part of this. And you come from all across campus with a variety of views and approaches, which is really interesting. Your outcome can be anything: a paper, a discovery, a failure, a startup, a success, or whatever. It's your own idea. That's the important part. Nobody's telling you what you should be working on. And it's rare that an undergraduate gets that opportunity. If you get a research assignment, ordinarily you go to a lab with a faculty member and you do the things they're looking at. Here you're doing what you wanted to do. And I know you've been able to basically express yourself. It's a great experience for you. And that's one of the key attributes of this program. So it comes out of the internet room. That is the first router, as you know. That's just down the hall in 3420. Here we are in the connection lab. It looks like this, it looks like that. Okay. Now, in terms of the mentors, we've had a number of mentors all throughout this period, and here they are. That's the set. We can always add to this list as well, but we select from this group, and as you know, the way the winners are selected is that the applications come in, we present it to the mentors. If they like one, they pick it, and that's a winner. This year we have 8 new winners coming up. The graduating class, you had 7, one person dropped out, so there's 6. And these are this year's mentors. You can recognize each of your mentors there. Just to give you a heads up, next year's prize winners are these. It's Henry, who's in the corner there. Nicola, Hannah, Minnie, Jessica, Mia, and Joshua, and Seraphin. I hope I got that name right. That's what was on the application. He may have given his name twice, I'm not sure, but anyway, that person. Here's the topics and their mentors: name, data, networking. I'll be the mentor. Low-cost physical therapy sensors. Venki's the mentor. Queer adolescence issues. Miriam Posner's the mentor. Refugee child education. Amit Sahai. Predicting New Hawaiian, I think it is, and what is the PI? Pacific Islanders and the access they have. Our dean is going to handle that. She was thinking she might appear today. She still might to attend. We invited the mentors. Most of them couldn't come. Hyperconsumption, Sophia Noble. Social media self-ID issues, Lillian Corral. And better advanced strategy, Jeff Beck. So those are the topics for this coming year. So I congratulate all of you again who are graduating. It is our 6th graduation year. You've gone through all these issues, the pain and the pleasure of doing the individual research, and it contains both. It's a learning experience. You've all bumped into some kind of problems. The trick is to get around them and not give up. There are barriers, and then you lead to successes, breakthroughs, hopefully, organization issue, and access to data, need to pivot, and last of all, as often happens, you run out of time. You don't basically monitor and ration your time appropriately. I haven't heard any serious issues in this group, but in the past, people just wait too long to get to the meat of their project. They spend a lot of time preparing, getting data, thinking about it, and leaving everything for the last quarter to execute, to write it up, to test, to redo. Anyway, I'm telling you mostly, Henry, you got to watch out how you schedule your time. We'll make a big deal of that at the kickoff in the fall. But again, the big benefit is doing things on your own term with colleagues. All of you are now members of a community of past recipients. That networking function has not been tuned very well. We're trying to do it better, but to the extent that you can interact not only with your peers of this class, but previous ones and future ones, it is a set of colleagues that you should stay in touch with throughout your career. So our graduating class this year is Rhea, Olivia, Kaushik, Amir, Zifan, Maya. The topics to remind you: health equity, the mentor is Jayati Murthy; gesture control from Olivia, Jeff Burgundy, mentor; crypto firewall, Kaushik, Frankie Hawaiian; Amir, misinformation issue, Amit Sahai; Zifan Hey, peer-to-peer file backup, I'm the mentor; and Maya, cloud service, environment, help me with the other words. One is government. What's the S? Social and government. Ajit Ghai. So, you all have been asked to, and I know you've succeeded in addressing the 4-quadrant template, which is sort of the guideline for what you're doing. The upper left-hand corner is the title and topic, what's new about what you did, what process did you go through, and what are the results. Very simple, key foci for you to think about. So, let the games begin. I'm going to let Bill introduce each of you and have you go. And I'm going to leave this HDMI plug for you to plug in, and this is the laser pointer for you to use. So, have at it.
Congratulations again for graduating from IRI, and it's time for you to present your final outcome. So the first one is Ria.
This will happen to everybody. Presentation mode may take over.
Is it that one?
You can try to.
I think it's this one. Is it
No,
this one?
no, Apple TV. You are using.
Is it mirroring the screen?
You can try it like this. You can see from the screen.
Oh, there we go.
Yeah,
Yeah, okay. Okay. A second. I'm going to have to use this. All right. There we go. All right. All right. Hello, everybody. My name is Ria Churi. I'm going to be presenting on the HEAL project under Dr. Jayathi Murthy with the IRI. So just a little bit about me. I'm originally from Arizona, came to California for UCLA. I'm a fourth-year neuroscience major, so I am graduating next week. Very exciting. I'm a global health minor. This is what got me involved in healthcare equity and actually how I found the Internet Research Initiative. I also wanted to give a little shout out to my parents who couldn't be with me here today, but I'm sure would have loved to. So starting off with some background. So the average hospital spending for a 3-day stay in the United States for an insured person is around $40,000. For an uninsured person, you're talking around $60,000. Just to put that in comparison, that's around a down payment on a house or a new Tesla. So very, very expensive. Among racial and ethnic groups, they typically suffer the worst outcomes in healthcare. They have high rates of infant mortality. They're 15 to 20% more likely to die in hospitals, and they also have a lack of access to traditional medicine. Other marginalized groups also face similar issues, so there is definitely a need for equity. So the question we wanted to focus on is, are doctors and hospitals doing the best for us? So the HEAL project was founded on this question. It stands for Health Equity and Accessibility for All. and it's formed to combat discrimination in the medical system. So how do we do this? So first off, to start off, we wanted to crowdsource from the populations that were being affected. So these are marginalized areas and marginalized groups. We wanted to get surveys to get their input on the medical experiences they were facing. So this was done through anonymous forms. The forms asked a variety of questions, being demographics, socioeconomic status, a review of healthcare options and experiences, and suggestions they had about the healthcare system. Our pilot program was done with the unhoused population in Los Angeles. So this is around 76% of our data collection, which equates to around 95 participants. We partnered with the Mobile Clinic Project, which works in West LA primarily. We then expanded to student groups at UCLA and natives of LA to get their input as well. And then from these results, originally we wanted to build a Yelp review site. Unfortunately, because of some barriers that didn't get there, but we started working on a public health paper, which is currently being reviewed by the public health school here with a hope to be published, and a telehealth movement, which I will go into explanations further. So moving on to our results. So our paper primarily focuses on six main solutions we want to implement in the healthcare system. The first being an emphasis on the social history form. So what the social history form is typically when you go into a doctor's office, they will take your medical history, asking about medications, whatsoever, and then usually a social history is given. This is because we as humans are social beings. Our environments and the people we interact with influence the disease and the infections we get. To give you an example of why this social history form is so important and so needed is we actually had a participant who shared a story with us. He went into a traditional hospital. A lot of times in a traditional hospital setting, doctors are seeing a lot of patients at once. They try to go as quickly as possible, and usually, most of the times, they'll try to get through as much of the medical history as possible. So he had kind of blueness in his legs. His legs were kind of losing blood. The doctor took his medical history, diagnosed him with deep vein thrombosis, which is basically where you get a blood clot in your legs and your legs aren't getting adequate blood. He took the medication for that, it wasn't working, thought he was gonna have to go in for surgery. He decided to come to us at clinic. They took the social history form. They actually found out he was around people who had been diagnosed with meningitis B. Meningitis B also can cause you to lose blood flow to your legs. And in this case, if he hadn't come in when he did, they would have had to amputate his legs. So very lucky that he came in when he did, and that is why that form is so important. The next issue I want to go into is an access to telehealth. So usually in marginalized populations, especially the unhoused, they do not have stable internet access, they do not have stable phones. I think we've seen with the pandemic how important phone and internet access is, especially in the healthcare system. People use it to find COVID tests, to go to their doctors online, to access their mental health. But unfortunately, if you don't have it, you can't use it. So in this day and age, you don't have access to a phone, society kind of keeps moving on without you. Very, very important. Some other suggestions we had was a patient to client focus. So this is when, instead of referring to somebody who comes into a medical setting as a patient, you refer to them as a client. This just is a linguistic change, makes them feel more part of the process that they're in. A lot of times clients are more active in their own medical care. They build an action plan together. They typically are more willing to hear what the doctor is saying and willing to listen and enact actual medical plans. Another big issue is the ignorance issue or an awareness of discrimination. Discrimination in the healthcare sphere typically is ignored for two reasons. One, because it's unknown. A lot of traditional healthcare settings use medical tools that were built for primarily white people and do not account for black or brown bodies. The second, because it's unexpected. So we actually had a participant who identified as a black woman who shared with us an experience she had where she had severe cramps in her abdomen. She went into the hospital hoping to get checked out, wasn't seen for 4 hours. When she was, the nurses decided to say that she was pregnant and tried to push her off to the labor and delivery / fertility wards, get her seen there. She was very adamant that she was not pregnant. When she finally was seen, she was diagnosed with endometriosis, which very painful disorder in the uterus. With this comes data sharing. So hospitals typically want to preserve their reputations. Unfortunately, that doesn't always work out for us because you should know the type of care you're getting into. What this means is a lot of times hospitals don't share their survival rates among different racial or ethnic groups, different marginalized groups. which can be very damaging. We were very lucky to get an interview by a person who decided to remain anonymous but used to work in hospital administration, who had said that they had worked with data that had shown that Black people in their hospitals died at rates 2 times higher than white people. So very, very important that people know what they're getting into. Lastly, with all this type of research, universal healthcare should always, always, always be an option for people. As we saw, insurance is skyrocketing in this day and age. Medical care is not exactly accessible or affordable, so very important. So moving on to our future steps. So we are currently working on the telehealth movement at this point in time. We are trying to bring access to phones to people who don't have it. What that means is we are partnering with service companies who are giving us older and cheaper models of phones with a low-cost internet service package or a free internet service package. So actually, I think in about a month's time, we're planning to deliver 20 to 30 phones to the unhoused population in Los Angeles, thanks to AT&T providers. So very good. Additionally, we want to partner with other colleges around the US. This is because a lot of passion is found within these areas, and typically students are very adamant about this sort of work. On top of that, a lot of hospitals are close to campus, so it's very easy to do research around these areas, but we do want to expand to a citywide focus later on. But long term, we definitely still want to build the accessible reviewable site and platform. I think our first goal is trying to provide internet service to people who don't have it. And then we want to push hospitals to share the data that they have. So thank you so much to my mentor, to the IRI board. This was a really, really great project for me. I'm super planning to go into public health and healthcare equity, so I was very glad I got the chance. And through it, I actually found a lot more issues than I previously thought. So thank you so much.
One question. The phone. How inexpensive are they?
So we were actually, these ones, they gave us, I think, a 6-month package for around $10 a month or something.
What about the cost of the physical phone?
The cost of the physical phone, I don't have that off. I think it's something around $100, I want to say, but they're like willing to donate it to us.
There was a number of feature phones coming out on the road that are $50
Yeah.
quite functional.
Yeah, so that's also like something we're planning to look into. But yeah, for now we were just kind of trying to get like older models and cheap phone access out there.
Good. Very good. Very nice.
Thank you so much, Ria. And next we are welcome Olivia to make the presentation.
Are you going to run a demo or not?
Great, I'll begin. So my project is called Dolly, and essentially I made a robotic dolly that can be controlled using gestures. And my project is basically on gesture-controlled automation for remote filmmaking. So just an introduction, my name is Olivia. I am currently a senior this year and also graduating very soon. I'm majoring in computer engineering and I'm minoring in film. My project is on gesture-controlled automation for remote filmmaking, and my mentor, who helped me a lot on this project, is Professor Jeff Burke. All right, so I'll just begin with the overall idea for this robotic dolly. So the motivation behind Dolly is basically the effects of COVID on the film industry in the past couple of years. So the film industry is a really social, collaborative, and practical field. And due to social distancing, there was a massive film production slowdown. And people have developed technologies such as remote filmmaking and virtual production that helps mitigate the slowdown, since with remote filmmaking, you won't have as many crew members on set, since some of them will be working remote and can see the set from their own home. And the only downsides to this sort of technology is that it's not really an intimate like filming experience, because they're only able to observe, and they're not really able to partake in filmmaking. So the goal of my project is to enhance remote filmmaking by integrating gesture control to create a better filming experience and also a convenient user interface. So a little bit of background. So current remote filmmaking software facilitates a high-quality end-to-end live streaming service. And I think that's the extent of remote filmmaking at this stage. And gesture control has been implemented in automobiles and smartphone, but it's not really something that has been implemented in filmmaking yet. So this would be a new application for gesture control. And through my project, I propose to investigate the applications of gesture control as a new form of teleoperation for physical virtual work. So before diving really deep into this project, I did kind of a field study and also found use cases for remote gestural control. So I went around to a couple of my film professors and asked them, questions like, when is gestural control useful? And a lot of them responded that they really like the subtlety and the dynamic range of using their fingers to control things, as opposed to pressing buttons or using voice control. And this is especially for the professors who work in cinematography, where they have to work with cameras most of the time with their hands. And then I also asked them questions about when remote control is useful. So remote control is definitely useful during the pandemic, when crew members need to quarantine. They could still be present on set through remote control. And beyond the pandemic, remote control is also useful for when crews are shooting at overseas locations. So this means with remote control, you fly less crew out to locations, and you can cut down on travel costs. Another thing it's useful for is operating really large equipment, often on really big film sets, such as lighting equipment, jibs, dollies, cranes, and also mechanical effects on really large-scale productions. And another thing it's applicable for is filming in difficult situations, such as aerial shots, underwater shots, or severely cold or hot climates. So here are a couple of use cases that I gauged from the different professors that I've talked to, and they all have different roles in the film industry. So the professor, who is a cinematographer, said that the use case for cinematographers would be to smoothly control fluid head tripods to produce subtle moves in a shot. And basically a fluid head tripod is a tripod that has smooth analog control, as opposed to a gearhead tripod where it snaps at the gears. So they said that using hand gestures would be really ideal to control something fluid and continuous. And then this is also really applicable for actors, since in fantasy films, sometimes they have telekinesis and special effects, and this can be simulated with the actor's own action instead of automated mechanical effects, and this could help the actors more naturally drive their own acting. And then lastly, for directors, on large film shoots, there typically are 2 directors, and the main director is doing a main shoot, and the second director is doing extra scenes probably at another location. And sometimes when they need to communicate, it's a little bit hard, so remote filmmaking would help main directors communicate with their splinter or second crew. So with that motivation, I decided to work on a robotic dolly. And this robotic dolly can be controlled using hand gesture and movements, which is recognized through your own laptop. And your laptop will transmit these detected gestures via the internet to wherever your film dolly is located. And then your film dolly would execute audio cues, movement, and then the camera feed would also be transmitted back to the user so they could view what is happening through the dolly. So this is the progress that I've made so far on this project. So in terms of hand gestures and movements, deciding which gestures to use. So the main objective for this is to find the gestures that are the most intuitive and natural. So there's a lot of different filmmakers with different roles on set. And for the purposes of my project, I decided to focus more on the cinematographer that is operating the dolly. And for this, I decided to choose 4 hand signals. Typically, when you want to begin shooting, you call camera rolling. And I used a cue signal for that. Camera rolling would be an audio cue where your dolly would have a speaker attached to it and just say out camera rolling. And then another hand gesture is palm up, which you would use to move your dolly forwards, backwards, or forwards, backwards, left, and right. And then to stop the dolly, you would make a fist. So you would palm up and then stop. And to stop the recording, you could just call cut. Great. So the next step in this project was how to recognize these hand gestures and movements. So for hand gesture recognition, I chose to use computer vision because with computer vision, it's completely contactless. You would just need a simple webcam, and this is definitely better for people who don't have much experience, or it's like less bulky for when you have sensors attached, like glove sensors that you have to wear to control things. So in that sense, computer vision is definitely better in the sense that it's more contactless. And then some of the cons of computer vision that I've noticed is the change in lighting conditions, occlusion, and also background colors, depending on the vision technique. Actually, during this research project, I've come across issues with background colors where I was wearing a jacket with like stripes, and it would recognize that as fingers. So that was a really interesting that I discovered. And then out of the many different computer vision techniques to recognizing hand gestures, there is the color technique where you would detect your skin color. There's also the appearance technique where you would try to find the foreground and the background and separate an image into that. And I decided to settle with the skeletal method because with the skeletal method, you would perform hand segmentation by calculating all these 3D joints on your hand. There's 21 of them. And you would also be able to calculate the distance between these joints. And this is particularly good for dynamic hand gesture recognition instead of static hand gesture recognition. And then there is a MediaPipe API that is really robust, and it uses regression to locate these 3D points on your hand. And that is the open source tool that I used in this project, as well as the TensorFlow library, where it would take in these 21 points and produce a class probability, which would tell you which gesture it detected. And then I also used this open source example on GitHub, which came with a pre-trained model and a data set of poses. And for the purposes of my project, I added additional poses specific to film and retrained the model. Right, so that part was hand gesture detection. So the next part is movement detection. So how do you know which direction your hand is moving in? So I decided to focus on the x-axis and also the z-axis. So the x-axis would be moving your hand from left to right. And then as you can see, there's an image of a bounding box. And then the 2 arrows signify the direction that your hand is moving in. So I decided to use a midpoint of the bounding box to determine whether there has been movement on the x-axis. And then as for the z-axis, I determined 2 metrics that can determine whether you're moving your hand forwards and backwards. So one of them is using the length of the bounding box, which is also the length of your hand, which should be static. And then also the area of your bounding box. So if you move your hand closer to a webcam, you probably notice that it appears larger, and then versus like when you move it back, it looks smaller. So that was kind of the way to detect whether you're moving forwards and backwards. So I decided to use regression to kind of solve this issue for depth and determine which function to use to kind of like calculate how far your hand is from the screen. So this is kind of like an ideal situation. So this thing over here would represent your computer screen, and then Y is in terms of like how many pixels are in your frame. And then the X would be your hand, like how many pixels your hand is taking up. And then what I want to calculate is the Z, which is the distance between the hand and the screen. And then I did some mathematical calculations where I derived kind of like a linear function. And then I also collected some data around like 30 data points from like various like centimeter lengths away from the camera. And then as you can see, there's a little bit of like noise. It's a little bit skewed. It doesn't really look like a straight line. And then this was the linear function that I fit using this data using least squares regression. And then lastly, the second metric is area. So I've noticed that with area, using a quadratic model to like model area yields a lower bias and variance in comparison to distance. So in the end, the model that my robot is currently implementing is area. And then also I've realized that after like calculating the area or the area and distance function for the bounding box, the result that you get is kind of like noisy, because MediaPipe, when it like locates those 3D points, occasionally it does get a little bit erratic. Sometimes the points are not like accurate. And so to do noise corrections, what I did was I used the, I first took the function, like the area versus time. So I would, every like 0.2 seconds, I would like calculate the difference in area of the hand's bounding box, and then kind of like multiply that with the results from the function I got previously to determine the instantaneous or the approximate instantaneous velocity of your hand. And after getting these results, it was like really noisy. Sometimes occasionally it would like, you would get like really large or really small values that didn't really make sense. So to kind of filter out those values, I had like a lower and upper threshold to kind of cut out those values. And then after that, I have this like smaller range of values that I map to a suitable value for varying speed. And then for my robot, I set a baseline speed, and then I would add this varying speed value to it. So the robot would subtly like speed up if your hand is going faster, or if your program determines a larger velocity, a little bit slower if it's slower. Right, so as for transmitting the detected gestures and movements via the internet, I decided to go with unidirectional communication with a kind of a traditional server-client model, where like the server is your laptop and then the client is your receiving dolly. And for this, I used the MQTT protocol, which is really good for publishing and subscribing to really organized topics. It's also really suitable for controlling IoT devices, and it's really lightweight, which makes it easy to implement for a small prototype that I did, and also low power consumption. This protocol is also like, you could also perform bidirectional communication using this protocol, but for the purposes of like keeping my project simple, I just used unidirectional communication. Right, and lastly, executing audio cues and the dolly movement. So executing the dolly movement, I have a Raspberry Pi that is tethered to the dolly, and then essentially your laptop will send these detected gestures and movements to your Raspberry Pi, and your Raspberry Pi will then execute these movements. And so for robot design, I really wanted to simulate a real-life film dolly. So typically, film dollies are often situated on tracks, like the one that you see here. And a dolly shot is created when the dolly moves along the tracks smoothly. And these tracks are generally two-directional, forwards, backwards, right, and left. So in order to do that, I decided to go with mecanum wheels, which allows you to smoothly roll forwards, backwards, left, and right. And it doesn't require the robot to turn to go right or left. And the motors are also driven by PWM pins from the Raspberry Pi to control the speed. So as you can see here, there's different duty cycles, 0 for like slow, and then 100 is like the fastest speed possible. And then as I mentioned before, I did like a mapping of the speed. That mapping was to get it to fit within the correct duty cycle, which I then pass on to the Raspberry Pi to execute. Right, so I'll go into the results. So after building this very small prototype, this is the whole system. You have your hand gestures and movements, and your laptop recognizes them, transmits them to the Raspberry Pi, which then will execute audio cues and also the dolly movement. And then another thing I had was tethered onto the Raspberry Pi, I put like my iPhone camera and set it up with Zoom so that when you open up Zoom on your laptop, you can see what the dolly is seeing. And that's kind of how I conducted the user study. I had 6 users, and they were asked to move the dolly around to frame the shot of an apple and a rose lying next to each other. For the demo video, let me bring this up. So this is like a video of, sorry, let me turn down the speed, or sorry, the volume. Yeah, so as you can see here, I have my friend at the lab testing out the robot, and she's trying to get it close to the apple, and then she's trying to position it a little bit. And then as you can see on the laptop screen, it's a little bit hard to see, but she can see what the dolly is seeing. The apple is getting larger. Yeah. And let me show the same video from a different perspective. So this is a screen recording of what she's seeing, basically. So she can see her own hand gestures, and she can also see what's going on through the dolly. Great. So I think one issue that I faced with this kind of a user study is that this project is intended to be used remotely. And my friends were here at the lab, and they were able to see the objects next to them. So they weren't completely relying on like the screen that they see over Zoom. They were also looking at the objects beside them, and then kind of like looking at them, and then moving the robot that way.
Cheating.
Yeah. And then, so I decided to test it with my dad, who is currently in San Jose. And then here's how it went. So as you can see, there's no one but me in the lab. And my dad is sitting at our house trying to control the robot. He's not doing a very good job of it, but It took him like more trials to kind of like get the hang of using the controls. So this was like kind of a test run where I let each of the users do a trial run where they could kind of learn how to use the controls before timing them as they did their tasks. Right. So this is another perspective. So this is my dad at home. He's trying to control the thing in the lab, and it's a little bit jerky. He's trying to get closer, but as you can see, the camera movement's a little bit jerky. Yeah. Okay. Yeah, these are just a couple of the videos that I have from user studies. And the results. So I conducted a survey with these students and also my dad. So with the tasks timing, each user took around 40 seconds to 70 seconds to complete the task of like moving the dolly towards the apple, framing it in the center of the shot, and then moving it left to the rose, and then also framing that in the shot. And then I also conducted a survey asking them questions and then having them rate from 1 to 5 how well they think the system performed. So for gestural control and the user interface, I asked them whether it was the controls were easy to learn, and they rated that as 4.8. And I also asked them whether they thought the interface was intuitive. And I also asked them whether they thought the gestures felt natural to them. And I also asked them how much lag they experienced while having the classifier detect their hand gestures. And for the most part, they were very satisfied with the gestural control and the user interface. For the remote control and the mechanical automation, so I asked them questions like whether the speed of the robot reflected the speed of their hand movement, and they rated that as a 2.5. So I don't think that came across as well during the user studies. And I also asked them whether the direction of the robot reflects their hand direction, because sometimes the robot doesn't go in the direction as intended. There's like a little bit of noise that I have yet to correct, so it kind of goes off. And I also asked them about lag. And lastly, I asked them about how it was filming with the Robotic Dolly. I asked them about the fluidity of the robot motion and did it feel cinematic to them, which they rated as a 3.5 around. And also I asked them whether they took a lot of time setting up a shot, traveling between the apple and the rose. And they rated that as 3.6. Right, so here are the conclusions that I came to with this project is that while using the MediaPipe open source tool for skeletal-based computer vision, yielded a lot of noise that did affect the program's performance. Another thing I noticed was that area seemed to be a more reliable metric than distance. Area is in the area of the bounding box of your hand versus the length of your hand. But this could also be affected by noise, so that is a possibility. And then another thing I noticed is that the users agreed that the hand gestures for controlling the robotic dolly felt very natural, but like another intended purpose of the dolly was to have the movement of the dolly match the movement of their hand. And they said that that didn't really reflect. So I think another thing I learned through this project is that the speed determined by pixel distance or area is actually harder to model than I expected. What I've noticed is that as I'm collecting data, when you use like a longer sample window, there's a higher accuracy, and also like the instantaneous velocity is not as accurate since there's a lot of jitter due to like inaccurate samples. So like prolonging the sample window would give you like the overall like distance over the time, which actually turns out to be more accurate. But there is like a trade-off. So with a shorter sampling window, within the loop, I can do processing faster and send messages faster, which allows the robot to move more fluidly. But with the longer sampling window, the robot is more jerky. So that was kind of the trade-offs that came into play during this project. All right, so for some of the next steps that I want to take with this project is look into techniques for better sampling and noise elimination. And then another issue that came up from the user study was that my friends said that they had to reset their hand motion. So what that meant was like when they were pushing forwards, their hand would be like too large for the screen. So then they'd have to stop, bring their hand back, and then keep pushing forward. So a lot of students found this like unnatural and cumbersome, and a lot of them suggested that when you move forward and hold your hand, the robot should continue moving forward. Another thing I think I would look into is definitely better hardware. Most students attributed the dissatisfaction of the mechanical automation to hardware limitations. So preferably motors with more torque, and also I would have PCB and soldered components instead of a breadboard and loose wires. And I think another thing to look into is optimizing algorithms. I wasn't really focusing on that. I was just kind of trying to come up with an algorithm, but it would be good to optimize them for less lag and higher efficiency. And then another thing that I could look into is using a third axis. So typically, when you're filming something, you have dollies, but you also have a camera that can tilt up and down, and that camera can also pan left and right. So those are like two additional like axes that you could experiment with, and probably different controls for that as well. And then here are some other applications of gestural controlled or remote gestural control. You could help the disabled, the elderly, also like physical labor, high-risk construction work, surgical robotics. Just because with remote gestural control, you're basically having an avatar in a different location, being your eyes and also like helping you like execute motion. So it would apply to a lot of other fields as well. So yeah, that's about it. Special acknowledgements. I wanted to thank, my mentor's not here today, but I wanted to thank him for giving me a lot of excellent resources, and also like helping me with like the film expertise and also like film technology. Also want to thank Professor Kleinrock for providing the opportunity for all of us to work on our own interdisciplinary project. And I really like this project because it combines my interest in both film and technology. And also thank you to Bill for always doing the behind the scenes and setting up meetings for us. And I also want to thank Professor Littenberg and Professor McDonald's. Both of them are film professors who provided me with some expertise in film production, and also gave some really good use case ideas with remote gestural control in filmmaking. Great.
Very nice. Let me point out that we expect to give not only quad shot presentation, put it on the website.
Okay.
You took a long time,
Sorry.
and I don't think everybody else can take that much time. We run way over, and we don't have the time limit. So if anybody expects to go that long, try to cut a little bit. It was very valuable. It was good. The fact that you did both the algorithm and the implementation, the hardware, that's well done.
Thank you so much, Olivia. So the next one is Kaushik for the presentation.
Does it do anything to turn it on? You're going to presentation, probably. Oh, sir. That should turn it on. Give it a moment. This, by the way, you can use this here. Place it with
Okay.
it if you want. Will, can we?
Okay, so good to see you all for the final time, and good to see the new learners. One of my buddies is here to see what I'm working on, so excited to share my progress this year. So my name is Kaushik, and this is the title I submitted to the IRI when I first applied. And really the motivation was I've been interested in security for as long as I can remember. In elementary school, I tried to hack video games to get free items because my parents wouldn't give me their credit card. And that's kind of where my interest in security started. Recently, there's been a trend of cryptocurrency photography coming into the mainstream. And I really think it's a wonderful technology. But we didn't have the security primitives that the modern internet has. Things like password managers, things like TLS certificates for HTTPS. What I wanted to do is bring the security-minded thinking to cryptocurrency to make it easy and user-friendly for everyone. So when I first started this project, I kind of just jumped right into writing code. And my initial idea was to kind of take this idea that today we have compilers for C, C++ that can detect things like buffer overflows, overflow attacks, and kind of bring these verification checks to cryptocurrency languages. So one interesting thing is typically when I write code, it's only for myself or for a school assignment. So what you're trying to do is trying to finish it as quickly as possible, hard code as many things as possible to get an A or to just get the job done. But this is the first time that I was writing code that was going to be open source. People can see it. Maybe future employers or one of you guys would view my code and say, hey, this code's trash. So what I wanted to do is make it really look really nice, make the design really nice, and this was my biggest mistake. So I spent a lot of time trying to make my solution really elegant, and unfortunately for me, while I was doing this, a bunch of people had the exact same idea as me and did it a lot better. So these are some of the popular tools today that come out in the past few months to kind of do everything I wanted to do but better. So I started to get really demotivated. And this is around December time. So I started talking to my mentor about what I could do, whether I should start from scratch. And he really encouraged me to look at what I had as a technology and apply it to something new. So I had a feeling that I could apply the same verification technology to cloud environments, but I wasn't sure if there was kind of a need for this. And I just happened to find out there was a cloud security conference happening in a month at that time. And this conference is for security practitioners, people who work at cloud companies and companies who consume cloud. So not really like an academic thing, more of a practitioner thing. And I just submitted this kind of title and a short abstract to see if people would be interested. But again, I wasn't really motivated to work on the project because I felt like I had to start from scratch. So I didn't have much progress for a couple weeks. Then one day I received this email that I got accepted to speak at this conference. The only problem was I didn't have anything to present. So I worked really fast to code a prototype and create a presentation. And I think the last time we met, 2 days after we had met, I presented at the conference. It was virtual this year because of COVID. And so while you're presenting, they have this artist who essentially draws like kind of a picture of what you've been talking about. So this is kind of the picture that came out of my talk. And it has some of the points and ideas that I wanted to kind of implement. And something that I was really proud of is while the talk was going on, they have a Slack channel and people are commenting live. And so when I joined the Zoom, there was 1,500 people watching. And I was so damn nervous. But then I started seeing these comments come in and the presentation went really well. This is my favorite comment. I was at home and I had the UCLA class on my bedroom and one guy commented about that. So these are some more comments that came in after my talk. And this motivated me. So I started to extend my idea to AWS environments, which is a lot more difficult than what I had done before for Google Cloud and Azure. And I submitted to a much more competitive conference. This is called Forward Cloud Security. And the kind of people who attend this conference is like CISOs, like C-level people, and people who are real security veterans. So this is kind of a long shot for me. So about 3-ish weeks ago, I got a update that I was not in the first batch that was selected. And the same day I got COVID, so I was really pissed off. And one thing they said was that the talk was extremely polarizing, and that I had made extraordinary claims and almost didn't back it up. So I was kind of sad about this for a couple days, and then I went to the website of Forward Cloud Security. And one interesting thing I noticed is the board of reviewers has 3 AWS employees on it. And I went back and read what I had submitted. And what I had submitted was a big critique of AWS, saying that what they had done was wrong and there was a much better way to do it. So then I started thinking, okay, the reason I got rejected is because they don't want someone coming up and saying what they had done was wrong. So for the next round, I submitted a much more balanced kind of abstract. And this was kind of promoting what they had done, but also suggesting an alternative. And really here I learned that it's not your idea that matters, it's how you present it and presenting it in the right way to the right audience. So 2 days ago I got accepted, and I'll be presenting in Boston on July 25th. And this is the day before AWS is a big security conference. It's called Reinforce. And one cool thing is I get a free ticket to that. I've always wanted to go, but it's too expensive. It's like $4,000. So I get a free ticket, so that's pretty dope. And yeah, I want to thank Professor Kleinrock, Bill, for organizing everything, and my mentor. Thank you.
What an interesting trajectory,
Yeah.
political as well as scientific.
Yeah. And I'll send an updated abstract for the website because my project has changed a lot.
How much reuse was there?
So
Submitted,
it's, oh, sorry, you're talking about,
each time you had a new presentation.
yeah. Okay, so the underlying idea of verification is the same, but the way it's applied is a little bit different. Like the interface, because AWS is a different interface than Google, etc. But the underlying idea of how we verify policies is the same.
So be able to make progress in improving security in any dimension?
Yeah, so what I'm presenting at this new conference is an improvement to a product AWS has called Zilkova, and that's their security verification product. And what I have done is created a similar verification tool that is less computationally intensive.
Another title for your work would be how to navigate the conference proposals to get accepted.
Yeah,
Oh, well,
thank you.
thank you. Before we go ahead, I want to remind you there are some refreshments in the back. If you don't eat them, and you get from somebody else, so please help yourself. Coffee, cookies, jelly, and
Soda.
drink. All unhealthy stuff. So,
Okay, thank you, Kaushik. So next one is Emil.
behind you. No, right there.
Oh.
Oh. Okay, hold on. I gotta do something. There you go. Okay. All right. Hello, everyone. My name is Amir. I am a fourth-year applied math major, and my mentor is Amit Sahai, and my project is called Misunderstood Information. So initially, when I started this project, I wanted to study how information travels in social networks. I was really interested in how people communicate with each other and how you try to model it using mathematics. So in applied math, one of our main objectives is to model anything. So one of the things that I'm really interested in modeling information. So when I met with my mentor, Amit Sahai, he was like, that's a very good idea, but like how are we going to start doing that? It's really difficult because people have been trying to do that for like the past 20 years. And usually modeling is not really it's not really a good practice, but he did say that you should try and look at what you did from your previous research. So my previous research that I looked into was vaccines and why people do not get vaccinated. So he basically suggested that I go into like looking into asking the problem, like what are the reasons for vaccine hesitancies in my country, which is Malaysia. So one of the major things that I wanted to ask is hold on. So in July 2021, last year, the vaccine rate in our country was 10%. So it was really low, right? But at the end of that year, our vaccine rate is 80%, which is like really impressive nationally, right? So if you're the news, if you're a politician, if you're like an economist, you would congratulate that as a huge success. But when you look into like the data on district, into like state level data, you would find a different story entirely. You have some states that have like a nearly 100% vaccination rate, but some other states that have like 60, 50% vaccination rate, which is really bad because like if there's like if there's a COVID outbreak in those states, then it's really going to affect that state or that district a lot more, and that's I guess the main problem that I see in the data. So vaccine rates, you can use it to measure the trust in public health and healthcare systems. They're free, they're public goods. So vaccine hesitancy is a manifestation of the free rider problem. It's a very famous problem in economics that when you have free stuff, people don't utilize it to its maximal efficiency. And so what I did, my process that I did was I collected a lot of data from Ministry of Health and demographic census from the Department of Statistics, and I performed exploratory data analysis. And what I found was really surprising because districts that have really low vaccination rates, they tend to not be the one that are the poorest. In fact, they're one of the highest. But those that have really wide ethnic disparities are the ones that suffers from this process. So if you want me to like show you some results, so this is the national full vaccination rate by ethnicity. You see that convergence between the different races, and there's another race there. So one of the assumptions that I made was that the census data was accurate, but unfortunately it's not. And in Malaysia we have a lot of undocumented immigrants that are not captured by census. So you see that extra bit for other ethnicity because they're not in the census at all. So you could also like make a new like research project, which is to estimate the population of undocumented immigrants in Malaysia based on the vaccination data if you're future projects. But as you can see, like the national data looks really nice. There's a convergence there. And I thought, okay, there's nothing wrong with that, right? Until I look at booster rates by ethnicity. And this is when it gets really, really interesting. So you have the Chinese population, Chinese community, with a lot of booster rates, Indian and Malay and Indian communities on the other hand, suffers from a lower vaccination rate. So I asked myself, why is that? Like what is what is the mechanism involved in that? And can I see that in other states? If I see this nationally, like how would it look like in individual states? And turns out, this is the lowest vaccination rate for a state. It's in Kelantan, it's in the north of the country. It's not exactly the richest state, but if you look at that disparity between the races, it's pretty big compared to the national data that we saw earlier, the convergence of the races. And here, it's really, really big, the disparity. So my question becomes, so my hypothesis completely changed. There is a connection between socioeconomic inequality and vaccine hesitancy within the Malaysian context. Unequal access to healthcare might be a factor behind mistrust of health and scientific professionals. So I started reading the history of public health in our country, try to dig out what is the trend that they have that actually led to this, this trend that we're seeing here. So if you want to understand the public health system in Malaysia, you should understand it through like 4 different paradigms. The first paradigm is the colonial paradigm. So we were colonized by the British, and they kind of brought in the first form of public health. And the public health that they introduced was mostly geared towards urban areas and economic engines of the colony. So a lot of healthcare institutions were built on like towns, and also like tin mines and rubber plantations. And in Malaysia, we don't really have segregation like we have in America, but we do have labor assignments that is segregated within ethnicity. So ethnic populations in Malaysia, it is segregated in a different way than America had. So our labor assignments are segregated between races. So you have the Malay people, which are mostly like concentrated in the subsistence farming, and Indian people are mostly work in rubber plantations. Chinese populations are usually they work in tin mines. So you have a strict labor division that is based on like colonial rule. And when Malaysia did achieve independence in 1957, the government inherited a deeply unequal healthcare system. 70% of like healthcare institutions in Malaysia after independence mostly serve 40% of the population. So it was really, really huge inequality there. And then between this period too, that there was a huge communist insurgency. So the government decided to use public health in order to like combat the influence of communism. So they built a lot of healthcare institutions in Chinese communities because Chinese communities were really active in communist activities during this period of time, which really boils down to like a huge racial conflict in 1969. In the 60s, there was a period of conflicts, and the government decided to introduce affirmative action policies to correct the inequalities that they have seen from the previous years. So by the end of the 70s, you have a network of rural hospitals that are generally well-funded, generally have like healthcare professionals that are equipped to do the job. Until the 1980s, what happened was the government decided to pursue a more privatized or corporatized medical policy, which made a lot of the rural hospitals underfunded, and the quality of healthcare in like rural areas generally deteriorated. So like this is what you what you see in this trend right now. So what I did was so for the next steps, I have to finalize the candidate statistical measure of vaccine inequality. So there are 2 like competing metric that I can think of right now, and the first one is the Gini based. So Gini, you just if I may. So you have a graph. It's okay. Essentially, like you have a So essentially a Gini based like okay. No worries, no worries. So it's essentially a Gini is like you draw a graph and you draw a straight line, right? And then you try to compare it with like the real distribution. Like the farther away from that line, the worse the score is. So that's how a Gini coefficient can be calculated using vaccine inequality. Generalized entropy based, I'm sure you guys are aware, the computer science people, to measure entropy, which is redundancies in the data. So you get like data compression. That means that there's a really big inequality there. So there are two like economics that I'm using right now. Right now I'm trying to identify all the relevant variables. I'm collecting all the data of all the variables I can get as much as I can get. And then what I do after that is I use variable selection to cut down the variables that I needed to measure, and then I run OLS, and then I do regression diagnostics. So I'm planning to do this over the summer, and I'm currently working with a research team to do this. Basically, we're taking as much data as we can on all these districts, their racial makeup, their income inequality. We want to see what kind of variables are there. We want to make sure that that hypothesis earlier that we mentioned, ethnic disparity, is not, that there's not a confounding variable that could exist when we do all this, when we do OLS. So this is the best performing district in the worst state. Look at that convergence between the three major races, and then the worst performing district. Look at that major disparity there. So we really see this throughout the country. We're not just seeing it in certain states. And the state, like, there was one notable state, which is Sarawak. It had a pretty good healthcare system. They decided to not pursue a privatization policy during the 1980s. And they actually did focus a lot more on equity in terms of providing healthcare systems. And we don't see this at all in the districts of that state. Which we really think that it could be a reason why the trend forms. And if you look at the Klang Valley, which is the major urban center of our country, there's a pretty good convergence here. But of course, that you have the census data that doesn't really capture the undocumented immigrants. So yeah, this is the booster rates. It did show some of that in the national data as well. All right, so acknowledgement, I would thank my professor, my advisor, Ms. Sahai, Professor Kleinrock, for allowing me to pursue this research. Federal Research Institute and Institute of Strategic International Studies, but they've been really helpful in providing me data and some advice in terms of what I should look for to describe the trends that I'm seeing. Because they've been studying this for like 20 years, and they haven't just looked at vaccines. They looked at obesity. They looked at cigarette smoking. They looked at a lot of these health, I would say like bad health habits, and they found the same thing as what I found. Like a lot of the districts that have like really bad like smoking rates are also districts that are really unequal. Not necessarily the poorest, but really unequal. So hence like the trend is like really clear. If I could show this for like other countries like America or like another context, and I think this is a really interesting idea of inequality being detrimental to conducting public health measures. How inequality can actually obstruct public health from achieving its full potential. And I think this is a really important problem that we need to face with in the current year. Any questions?
The comment you made about the vaccination rates being
next one is D5.
Oh, it's a bit too large. Anyway, hi, I'm Zifan. I'm currently a third-year computer science and applied math major student, and my project name is Efficient Server-Mediated Peer-to-Peer Networks. And my mentor is Professor Kleinrock. And I want to first shout out to Professor Kleinrock for the help throughout the research and the draft of paper. Let me just, okay. Yeah, so here's my core chart, and I will cover all the 4 parts in the following slides. So first is my motivation. Conventional backup systems have several drawbacks. So we have 2 types. The first type is physical storage, like SSD hard drive, or you can use an array of hard drive like RAID. Sometimes it's really expensive to build such a system, and it's less flexible because you only have a fixed amount of storage, and it's hard to expand or shrink if you don't need that much. An alternative now is cloud storage, but the drawback is it's charged monthly instead of one time, and there's lack of privacy. Like we don't know what the Google will do on the data in your G drive. So I look at peer-to-peer network because it's famous for privacy due to its system structure. It's currently really useful in file transferring and sharing, but I thought that would be really helpful for file backup as well. We can actually store files in others' computer. So there's a huge difference between peer-to-peer networks and the common server client system used by the cloud storage. So we need to think about some extra questions when we design it and make it more efficient. Like how can we search and upload the file quickly? How should we cut the file into several chunks and make use more spaces? And how to do version control, like if you want to update some files. So I just picked the first question in this year because I need to focus on one aspect of the design. So in order to do all the analysis, we need to determine a specific peer-to-peer network system. There are lots of systems. Currently, most researchers are working on a type of network called unstructured peer-to-peer network, which doesn't have the central server. Never mind. The central server over there. Oh, it doesn't have the central server, but now this structure is a hybrid model which has both has a central server that accepts the request from a peer in a peer cluster and tell all the trusted peers to search through the network. We have a cache here. It's just used for storing the search history so that if someone searches for the same file, we can just grab it instead of do the flooding search again. Now we determine the whole system. In order to do the mathematical analysis, we need to abstract into some mathematic models. Since it is hard to obtain the real data, a good model for peer-to-peer network is a random graph. And we choose a subset of the random graph. It's called it's a configuration model with a power law degree distribution. By power law degree distribution, it means the distribution of degree, which it means how many wires connects to the nodes, follows the power law, which is something like some distribution with exponents. So why we choose this model is because we have the intuition that if a node has more connection, it is more likely to be fine, and a new node would tend to connect to those peers. That is this graph generation is usually called Barabasi-Albert model, and the result is the degree distribution is power law. And what is a configuration model? It's a type of random model that we are given a degree sequence. Like here is 3, 2, 2, 1. And every time we pick two nodes, make a connection if there are some remaining stubs. The stubs means this small green chunk of nodes. Yeah. And after all those stubs are used up, we will have a graph which is one of these 6. Now we have the model. Let's think about what's our goal of analysis. So to improve the searching efficiency, we mainly have 2 goals. We first want to find out the average number of hops required to reach a file. And the second goal is we want to construct a cost function after we get the number of hops, and we want to minimize it. So the first step is computing the average number of hops needed. So here I have a graph about my network. It looks like a neural network, but it's not, because it's actually the node in a later layer can actually connect to the previous layer. And the green dots are the trusted nodes. They have degree L, and the other nodes are just normal nodes with degree C. So the first step is we want to find out how many neighbors are connected to the trusted nodes, which are in the blue square. And the way I calculate is I first calculate the neighbor of the first trusted nodes, and then when I calculate the second trusted node, I need to remove if there is any overlap with the neighbors of first trusted node. So the result is such a recursive relationship. And for this recursive relationship, there is a closed form. You can find it in my paper, but I just skipped it. And next, I'm going to find how many neighbors are connected to the neighbors that are flooded by the trusted nodes. Like, it's another recursive relationship over here. This recursive relationship is more complicated. It involves 2 variables, and I think I can't find a closed form, so I do an approximation. Yeah. So when should we stop? We need to have a criteria that's saying that we already found a replica or a file. So there are 2 types of stopping criteria I found. The first one is really intuitive. It's called node coverage. It basically counts the fraction of nodes visited in the network should be larger than the average probability to hit a file replica. When it's larger, we would just stop. The other criteria is called minimum average shortest path. It means finding the minimum of average shortest path to each nodes across each trusted nodes. So why I have two types of stopping criteria? Because when I first do the research, I use node coverage. It's really easy to compute numerically, but it's really tedious to use this criteria to get an analytical solution. So I tried to find another way to compute it, and I found that MASP is better to compute analytically, and I use that for my analytical solution. So now we have some number to represent the minimum, like the number of hops to find a replica. Now we need to blend it into my cost function. So here is a cost function. What I found previously is the function W, and the cost function has two parts. The first part, the PT part, is the cost for running the trusted peers, because, for example, we need to run several AWS instances as the trusted peers, and yeah, it costs money. And the second part is the cost for searching. So the longer, the more hops you need to find a file, the more cost you will have. So after having all those informations, what we need to do is to solve an optimization problem. That is, we want to find such T that can minimize C. So to get an intuition, here is a graph for the cost. Like here, I draw it for two criteria. You can see that they almost have this similar result, but I checked, like from my research, I checked several number of P's and Q's, and I found in some cases the result is different. So the difference is shown on the following graph. So at certain ratio of P's and Q, the discrepancy is really small. So at these cases, using the MASP would be really easy. And so after I do an analysis, I need to do a simulation to see whether my analysis can predict the real situation. So here's my simulation code. It's written in NetworkX, it's Python. And here's my result. It's quite close to my expectation, because when you have a really small ratio of P's and Q's, you can't have too much trusted peers, because the majority is the cost of running the trusted peers. But if you have really high cost on the number of hops, you will see that there's a sudden drop when you increase the trusted peers, because the majority is searching. But after, if you increase too much on the trusted peers, the majority would become the cost of running the machine. We can do some extension because we have the cache. So if we have the cache, that means sometimes we can just grab from cache. So simply we just add. So H is the hit ratio, and if it missed, we do search. If it's not, we just don't do it. And we also need to have the cost of cache. So it's added here. It's CS. And yeah, that's basically a summary of my results. So other work and future goals. So all the results I talked previously has written in a paper and submitted to GlobalCom, which is a conference about networks and communication. And for the next research goal, I want to start researching on file fragmentation to improve the storage utilization. I've actually already started to write some simulation code on Python Network X and have some idea about analysis. It's basically built on top of my previous research, because now instead of having just the cost of searching, we also have the cost of uploading file, because sometimes the file chunk is too large that cannot fit into the granted storage of other nodes. So if the file chunk is too large, it needs to take longer time to find a place to put it. Yeah, that's all my presentation. Thank you.
So you found that a relatively small number of trusted nodes improved better than just one or no trusted nodes. It wasn't a very large number of trusted nodes. The moderate number of trusted nodes helped a lot.
On my graph, as some extreme case on my graph, I think there is a case that actually having 0 trusted nodes would be better. I didn't show on my slides, but at most of cases, having 1 trusted node is better.
Is that the case where the trusted nodes are very expensive to operate?
Yes.
Expected.
Like compared to the cost of searching, yeah. Yeah. Thank you.
Very good. That's the lead back to the time. You want to get to the certificate.
I'm going to be ready.
Oh, okay, go ahead.
Okay. Whoa, that is not. Okay. Hello, my name is Maya, and my presentation today is on ESG, or Environmental Social Governance, and Transparency for Cloud Service Providers. So first of all, an intro. My name is Maya. I'm a third-year computer science major with a minor in environmental systems and society. I like hiking, reading, writing, and other things. To introduce my project, so data centers, which are what we request when we're like requesting some sort of service, whether that's social media or like cloud computing services from a company. Data centers are what receive that request and then like serve it back to us. But they represent almost 2% of the world's energy consumption. So they use a lot of energy, and it's only going to increase as we become more reliant on the internet and technology. Many companies claim that their data centers run on 100% renewable energy, but in reality, most data centers are run using energy off the local grid, which is often like carbon-based or coal-based. And then they offset that data center energy usage using something called virtual power purchase agreements, which I'll get into. But essentially, it just means that although they're claiming to be 100% renewable and legally they can say that, that's not really the reality that's happening. So the goal for my project was to compare the true renewable energy usage of data centers, so what amount of renewable is coming off of the grid, to the claims that companies were making. And then so this is a lot of acronyms. The main thing that came into my project a lot was the middle one, virtual power purchase agreement. Essentially, it's like if Google has a data center in California that uses 100 megawatts of energy. Google can buy 100 megawatts of renewable energy in Virginia that's used to like power, like, I don't know, random homes in Virginia or something. But because Google legally owns that renewable energy, it can say that its data center in California is running on 100% renewable energy, even though it's just running on like carbon. So that is like the core of my project, to kind of piece apart how much of what they're claiming is through virtual power purchase agreements and how much is like actually from the grid. And then the motivation behind this project, first of all, shout out to Kaushik. You provided the idea of like looking into cloud service providers, especially with regards to their environmental and social impact. I think we've all seen how that metric has risen in the priorities of like investors and consumers and customers. And so that is something, because like climate change is a thing, we want to make sure that our companies are fulfilling the sustainability claims that they're making. Previous work in this area that really inspired my project was the Greenpeace Clicking Clean Virginia report. So this is a report that was written in 2019 that focused on data centers for a lot of kinds of data centers, not only cloud service providers in Virginia, which is the most popular location in America for data centers to exist, because the energy is like really cheap because it's really dirty. So that Greenpeace focused on that state, and then my project was focusing on cloud service providers in California and Oregon. And then I included the year differences because, you know, this one is like post or like during the pandemic, or like after the start of the pandemic, when, you know, internet use like has shot up since 2019. So the first part of my project was selecting companies to look at. Obviously, I wanted to look at market share because those are the most popular companies. As we expect, like AWS is at the top, and then Microsoft. There's also Alibaba, Google, IBM, and then some others. I cross-referenced the data center locations with like all the states because I wanted to find a region or a state that a majority of these top companies had data centers in, so that I could focus on that specific location. So yeah, I first settled on like all of these companies whose names you can see, but then I removed Alibaba, IBM, and Oracle because it was sometimes really difficult to find information. And then also Alibaba is not an American company, and I'm not as familiar with the laws and the energy regulation in China and like other countries that Alibaba operates compared to my familiarity with the laws in America. And then so my second part was analyzing the company's sustainability goals, so looking through their sustainability reports from past years, seeing which companies actually claim to be 100% renewable, which companies are actually doing something about it, and are those the same companies that are they doing both? For AWS and Amazon, the overall company goals were to be net zero carbon by 2040 and then power all their operations with 100% renewable energy by 2025. And then here we see that key term, 100% renewable energy. It isn't really 100% renewable energy. They're just trying to buy virtual power purchase agreements. Some of the, like, I guess, tangible things that they've done, they own, or they buy energy from a 47 megawatt wind farm in California, and then they also own a solar generation and storage farm in Imperial, California, and the energy for both of those is used to power their data centers, power their warehouses, along with like the coal-powered energy that they get from the grid. For Microsoft, the company goals are to be carbon negative by 2030, and then they also want to shift to 100% supply of renewable energy by 2025. I think something that was really interesting about Microsoft is that they differentiated between when renewable energy is coming off of the grid versus when they're claiming renewability through power purchase agreements. So that was something that I really respected, like their honesty about that. And then tangible items and actions that they've taken, they have a carbon tax that each division in the company needs to pay for its carbon emissions. So incentivizing, you know, divisions to keep their carbon emissions low. They've purchased 5.8 gigawatts of renewable energy through virtual power purchase agreements, and then their new data center that's currently being built in Sweden will be the first Microsoft region to actually use like low carbon renewable fuel for power. For Google, I mean, they were like by far like really impressive. They've been carbon neutral since 2007, aka they've bought like renewable energy credits to offset their emissions since 2007. They have matched 100% of their electricity use with renewable energy purchases since 2017, and then in 2020 they matched with 67% of their electricity usage on an hourly basis. So they're still, what that means is they're still buying renewable energy credits, but instead of just like evaluating how much energy they've used at the end of the year and then buying that, they're doing it on a more like on an hourly basis, so more immediate, which obviously that's not like a full solution, but I think it's getting closer to like the core of the issue. And then their main goal, they've already done a ton that all the other companies are trying to catch up to. Their main goal is to operate on carbon-free energy on an hourly basis by 2030 on the same grid where energy is consumed. So that's huge. That means even though like maybe the data center is still running on like coal-powered energy, on that same grid, so like still like in California, not in Virginia anymore. In my previous example, they are buying renewable energy. So it's getting closer and closer to the solution, or to the ideal of like everything running on renewable energy. And then so for my third part, which is evaluating, that was like the goals and the claims, and then evaluating the reality. I tried to find company reported data when possible, but most of the companies are not transparent whatsoever about A, the location of their data centers, which is understandable for security reasons, and then B, the energy usage and the computational power of their data centers. That's for competition reasons, which like I get it, but it was really frustrating. So yeah, I relied on company reported data when possible, but if not, then I would contact local government offices for their data center or backup generator capability information. But then sometimes even the local governments like were held under non-disclosure agreements by the companies themselves. So I was like, okay, like, what do I do now? So for AWS, I was able to find a report detailing some backup generators in Gilroy. So I estimated that their Californian data centers use 76.8 megawatts. Microsoft, I found a report saying that their Californian data center uses 77 megawatts. And then Google was the company that has the county under a non-disclosure agreement. So that, I thought that was really interesting. As for the actual green mix estimate that's coming from the grid that the data centers are running on, so for the Californian ones, I use PG&E, like runs most of the grid in California, so I just made the assumption that these are running off of the PG&E grid, and then there were reports saying that that grid is 33% renewable energy. For Google, their data centers in the Dalles are run by Bonneville Power Administration, which actually uses 90% renewable energy. So that was really impressive. Even though they don't say how much computational power it has, they do show that it is whatever it is, it's very renewable. So these are my like main results evaluating the three companies against each other. The first is Google. It is the most far ahead in their renewable energy goals, and even though most have been accomplished through virtual power purchase agreements, it does recognize the pitfalls of that and is moving beyond it in its solutions. It's also the most consistent in its reporting. It's very, very clear and transparent about the methodologies, the metrics. So I personally really liked that. First, it made my job a little bit easier, and then also I respect the company and the metrics of environmental social governance that does that. For Microsoft, I gave it like second place, but honestly I don't know if I would switch the two, because I felt like it was by far the most transparent and honest about its shortcomings when it comes to its renewable energy like strategies and initiatives. And it also had the most concrete actions and plans for sustainability. So like the other companies, you know, we always see like company, like the vague statements that are like supposed to be inspiring, but at least to me, it just seems like they're covering up like something. But Microsoft doesn't really have any of that. It was always very, very clear and like honest. And then third, and by far the last place, goes to Amazon and AWS. There was no transparency, no report of any goals or progress towards the goals. I even met with someone at I contacted offices and they directed me to someone at Amazon, and I met with that guy, and he was like, yeah, like, I forgot what he said. He said, like, at Amazon, we know that right now the public perception doesn't have to be we don't have to release this information because we don't care if the public perception of us is bad because we know eventually, like, we will be right. And I was like, that is the weirdest thing I've ever heard, but cool. So that really was disheartening, not only for like my project and my progress, but also for the fact that such like a company that controls so much of the market share has like fairly unethical practices when it comes to reporting. So that was very interesting. For final comments and deliverables, I will be compiling this into a report and submitting it to Greenpeace akin to the Click and Clean Virginia report. And then for future work, I think it would be really interesting to analyze company involvement with policy and lobbying. Google, again, is involved in this and lobbying lawmakers to add more green energy to the local grids and stuff. So I think that would be really interesting to look into. And then that's just my quad chart, summarizes his presentation. And then just to acknowledge Professor Kleinrock and Reiher for Professor Kleinrock for organizing this program, my mentor, Professor God, and the Smart Grid Energy Research Center, to Venki for funding this, because I think that research in this vein of the internet and society and like an impact is really, really important. And then to Bill for always organizing everything, thank you. And then to my fellow IRI cohort, I got a lot of ideas and inspiration from you guys, so I want to say thank you for that. And yeah, thank you.
I heard a talk today, this week, about some folks who furnished the data centers at the bottom of the deep sea to cool them,
Yeah.
which a portion of the energy use, of course.
Yeah, that was also an interesting thing because like Google was honest, like 4 places we can either run on like renewable energy, or we can have our data center be in a place that is cool. But like those 2 places, like you know, a cold and like windy or whatever, or not windy, place is not good for like generating solar power. So you have to make that trade-off because cooling is a really big part of the data center energy consumption. So I thought that was really interesting.
Well, it's an interesting trade-off if they do it under the ocean. They can get closer to shore, where a lot of the cities are, so the latency is less, whereas if you go to a place cheap energy, like you say, Virginia, you may not come here, or California, where you have to send the data and see the light. And you could put wind farms floating in the ocean right above them. But when they ask, what are you going to do to the ocean? And the answer is, we're not going to boil the ocean. Well, that was not a good idea. But that's very nice. Well, very nice. I like the breadth and the depth, and you guys have really come through in terms of choosing the best. I'm going to call a 5-minute bathroom break before we go to the meeting. 5 minutes. So So let me point out that it was a very fine set of presentations. You all matured into the roles, I'm very pleased to see. I'd like you to think a lot about in continuing with this community. And in fact, if any of you are around in the beginning of the fall quarter, you may want to come back and comment to the new incoming class about some of your experiences. You're welcome to do that. You're invited to participate in the kickoff. I know some of you are leaving physically. Let's see, we have, you are a new one also?
Yeah.
What's your name?
Joshua.
Oh, Joshua. And who's your mentor? Sophia, Miriam, Lillian, Jayati. Excuse me? Dr. Lillian Corral. Yeah, okay. Didn't mean. So very good. And what are you going to be working on?
So, my project is on perception of internet of social media users by other users. Like, for example, does a Twitter user view a Reddit user differently based off of how often they use that site, based off of like how often they like view posts from that website on their own website?
It's interesting.
Right? Because a lot of cross posting happens on the internet. If you build perception systems off of that. And I'm a psychology student, I like looking at perception stuff.
Great. I see that Henry is here also, so very good. But do feel free to engage. And by the way, while we have, you're here now, I know Kashik is outside, he'll be right in. Any comments from the graduating class about recommendations to improve the whole program? Well, that's a very good idea. We could announce it. Interestingly, we got a moderate number of applications this year. It was difficult for your year when the COVID was really on strongly. We couldn't reach out to classrooms to request, so there were few applications. This year we got a reasonably rich set of applications from which we can make selections. But opening up to the general community is a very good idea, especially for this graduation, to get some sense. If there are any other recommendations for how to reach out to the undergraduate populations to solicit yet more applications, or Richard said, maybe have some thoughts about that. Because it's, we go to some of the counselors and some of the student advisors and some of the department chairs and the administrative chairs to announce it, but I'm not sure it's getting out nearly as broadly as. See, before COVID, there were these large freshman classes, and very often we go to across campus, just either ask the professor or one of us would speak and point out the opportunity. That's not the case anymore. It's started to pick up again, but you're right about the level. Going after senior classes doesn't work. Yes.
Yeah, I think it'd be useful next year if you had like the students who are part of like the IRI, like the next graduating class,
Yeah, it's not.
doing tech, and then I was surprised to get it. I was like, oh, okay, perfect. And so I actually know somebody who's coming in, Minnie Eve, who's working in like global studies. That's like her major. And so she also asked me, she first came to me with like, is this like a very tech-based project? Like, am I going to have to?
Right.
No, this is not. Like,
Right.
this is just a research project. So I think like going out to maybe like the other side of campus and having the students market it over there, because I think a lot of students are like put off by the fact that like internet is in the name, they kind of like shut down immediately depending on their tech skills. So I think that's
We did try that in earlier years when there were large classes, but our outreach to that community is weaker than that in the science and engineering. So finding those people who can propagate the idea, but you're quite right. But having, you're saying some of you folks actually reaching out, too many of you are leaving, but but I'll reach out to those who are still around. You can be sure.
I was also
Right.
just saying like next class, like specifically for her, I know she's a global studies major.
Yes.
So it could be useful if she went to her classes and if she feels comfortable making a little speech about it when the application cycle is beginning.
Okay, will do, will do. We have had former graduates come back and talk to the class. It's been very helpful, by the way. Some of the graduates are more, we'll be done in about 10 minutes. Oh, Osana, you've come for the food. Osana, did Cassandra send you? Oh, she and someone's gonna come and collect all the rest of that food that we don't eat. I thought it was you. But take some anyway. Eat.
I was just checking if they did the job.
Oh.
Because
Oh.
they
Yes,
asked me
they-
to
yes,
confirm.
they did. Have something to eat. It's all unhealthy, be sure.
Thank you.
Sorry about that. Next time we're gonna get some fruit. Okay, any other suggestions?
Thank you, Professor.
Sure, pleasure.
Maybe like, I know it was the orientation, the student orientation, but like when you were in person, it was like a research, like what is it called? Like a presentation on like how to get research opportunities and what programs there are at the school. So I think if you introduce like students for that as they're coming in, that would definitely be something that.
You mean incoming freshman class to announce this among other opportunities?
Yeah, if you can somehow find your way to like get the name of the program into that one research presentation.
But that's, each school, each department probably does it differently. Like, to reach out to North Campus would be,
I don't think so. I mean, what I remember from my orientation was just like one big.
the official orientation.
Yeah,
Ah,
yeah.
okay.
Student,
That's very good.
student orientation.
That's good, because that's the time to announce it,
Yeah.
so that
A lot of people find-
about a quarter or two later is when the applications are requested. That's a good idea. Yeah.
I also think that a really valuable, and that's kind of distraction now, but like a really valuable thing to do would be like research workshops throughout the year, because like I feel like because my research was like very social sciencey, there's not a lot of like computer science and math involved in it. It's mostly like statistics work, and a lot of the ideas that I got was just because I took a specific class and I could see I could interpret the data based on the knowledge that we have on statistics. But I guess a lot of people they have to like read independently on the methodologies and how you should think about a problem, how you should frame a problem, for example. Things like almost like workshop.
You see, one of the things is we're looking for students who already have a passionate idea. I don't want to feed them an idea, because that's exactly opposite to what we want. So, but to be made aware that the opportunity is here, then to take their idea and grow with it is the advantage, as as all of you have had. You know, I mean, look at the variety of different topics and approaches that we've had in the solutions. Very different, and that enriches the whole program. And you heard Venki himself say that's what he's a venture capitalist. He's out there. He knows what sells and works, and he's thought through many different problems. So the fact that he sees value in this, and he has continually, is is really important. Well, I guess we're going to not wait for Kashuk. So, Bill, by the way, I want to call out, Bill is leaving us. He's graduating, damn it. So, congratulations. Thank you for your help. And Kenny Van back there has been so helpful in making the electronics and the availability work very well. So, Kenny, shout out to you as well. I mean, the fact that this works at all is a miracle. There's so many different parts. And all these ins and outs, different computers come out. Okay, so Bill, why don't you do the certificates? You all get a piece of paper saying you succeeded. So, congratulations to you all. Well done. Well done, and thank you. Sure, sure.